Hello everyone, welcome to the course of Process Modeling and Simulation, which I will teach you in this seventh semester. And our first module is related to the determination of physical properties and thermodynamic models. The textbook reference books which are recommended for this course: Chemical Process Design and Simulation, Aspen Plus and Aspen Hysis Applications by Juma A. Hedry. Second book is Aspen Plus Chemical Engineering Applications by Kamal I. M. Malah. Then Teach Yourself Basics of Aspen Plus, and then Using Aspen Plus in Thermodynamics, Learn Aspen Plus in 24 Hours, and Process Analysis and Simulation. So these are the six books which I will recommend you to go through during this course of process modeling and simulation. So in this first module, we will go through 12 exercises. Our first exercise is related to the determination of basic physical properties for pure components. Second one is related to the assistant property method. It is the same as we have discussed in our lecture number 1, part C, where we had discussed the thermodynamic property packages. Then ideal property method, vapor pressure determination, equation of state, Raoult's law, Henry's law. Then seventh activity is related to phase equilibrium and mixture. Eighth activity is related to TXY, PXY diagram, PT, XY diagrams. Activity number 9 is related to VLE behavior, vapor liquid equilibrium behavior with non-ideal property method. Number 10 is related to the unifac estimation. Number 11 is related to the data regression system in Aspen Plus. And 12 is related to the estimation of non-data bank components. So we will go through it one by one, and hopefully you will learn it easily. So our today's first task is related to activity number 1, where we have to determine the basic physical properties for pure components. What does that mean? That we will select a component which is a pure component, and then we will determine its physical properties. The objective of this simulation, please remember that when we will start a certain case, our first task will be to read the objective, that what we will achieve after doing this simulation. Knowing the structure of component in Aspen Plus, obviously you know the structure, for example the benzene, the structure of benzene, methanol, ethanol, for example, these structures you have already drawn and you know it, but you will also know the structure of these components in Aspen Plus, that how to assess access to these structures. Learn how to find and get the property value of pure component in simulation environment. Obviously you can also find it in literature, but when you are doing the simulation, what is the purpose of simulation? If you have to enter the value, मतलब अगर आपने ही वैल्यू देनी है सिमुलेशन में जाके, तो फिर उस सिमुलेशन करने का फायदा क्या होगा? तो आप ये भी देखेंगे कि वो जो प्रॉपर्टी वैल्यूज है उनको आप कैसे एक्सेस कर सकते हैं, क्योंकि वही जब आप सिमुलेशन परफॉर्म कर रहे होंगे तो वो वहीं से एस्पन की जो लाइब्रेरी में से असेस करके, एक्सेस करके, और आपके रिजल्ट्स आपको प्रोवाइड कर देगा. कैन ऑब्जर्व डिफरेंस विद आइडियल, इक्वेशन ऑफ स्टेट, EOS, activity coefficient model, property method. So basically what we will do, firstly we will know the structure of the component which we are going to select. Then we will determine its various properties which are present in the library of Aspen, and then we will do one case study, and we will observe difference between these three models: ideal, equation of state, and activity coefficient. We have already discussed these three in our thermodynamic property package selection lecture as well. What is the problem description? Find the following basic properties for number 1, methanol, which is at a flow rate of 100 kmol per hour at 60 degree Fahrenheit and 14.7 psia. This is the pressure, temperature, and flow rate of pure methanol. It means its composition will be 1. Then air, which is at 1000 SCFM, which stands for standard cubic feet per minute, at 75 degree Fahrenheit and 14.7 psi. So again, you see the same values are given, that flow rate, temperature, pressure, and composition is 1 because it's a pure component. Please use Aspen Plus to solve this problem. First thing is to determine the structure. Second thing is to determine molecular weight, density, specific gravity, critical temperature, and critical pressure. And then third task is to determine the viscosity, heat capacity, thermal conductivity, enthalpy, and vapor pressure. So we will discuss it one by one. I will firstly take you to the simulation procedure, because once you know the simulation procedure, it will be very easy for you to do these tasks in Aspen Plus. Our first task is to do the setup specifications, that we will go to setup and we will select appropriate unit for this process. This is MET, metric. C stands for temperature in degree centigrade. Bar stands for pressure in bar. Go to setup block and set a unit set as MET C bar. This is not a unit set present in the Aspen Plus. इसके अलावा भी और भी यूनिट सेट प्रेजेंट है एस्पन की लाइब्रेरी में. वो कौन कौन से हैं? इंग्लिश, metric, MET C bar, and SI. And in each case, if you see the units of temperature, Fahrenheit, Kelvin, degree centigrade, Kelvin. Similarly, the pressure, mass flow, mole flow, enthalpy flow, and volume flow are present. So I will show you once I will go to the Aspen Plus. So this is the first task which you need to do. Usually this METC bar is automatically selected. So if you want to switch to the English mode, you will scroll it down and select English or so on. After that, your second task is to select the component specification. There are two ways of doing it. Either you direct enter the name in component ID, or directly enter the name of component. This is one way of doing it, or enter the formula in alias. Second task, or the second way of doing it, to click on find and enter the name of the component which you want to search. Enter its name. As you see, air is written, and click on find now, and you see air is present. Then add selected components. Go to component block, specification, make component list. Put a component we want to find in blank block and find now. Select and add selected compounds. This is one is a compound, air, mixture of nitrogen and oxygen, but we will take it as a pure component. It will be a component. And for methanol, it's a single component. Same is the case for methanol. However, when you search more than one component, in this case, first you have selected air, then you have selected methanol. So it will ask, do you want to replace the component air with methanol or add methanol to the list? You want to add methanol to the list. You do not want to replace it. आपने air और methanol दोनों को add करना है. तो इसलिए आप जब ऐड का बटन क्लिक करेंगे तो मैथनॉल और वाटर दोनों इकट्ठे ऐड हो जाएंगे. अदरवाइज अगर आप रिप्लेस का बटन क्लिक कर देते हैं तो एयर रिमूव हो जाएगी और मैथनॉल ऐड हो जाएगी. सो इफ यू क्लिक ऑन रिप्लेस बटन, then air will be removed and methanol will be added, and so on when you will do it. Then the third task is to check the molecular structure. What you will do, you will click on molecular structure which is present below the specification. In specification, you had selected the components, and in molecular structure, you can see that once you click on calculate bond, after going to the structure, there are 5 tabs: general, functional group, formula, and structure. So first you need to go to the structure tab and then calculate bonds, and then you see the tick bar has been appeared on general and formula. Before that there was no tick on it. This tick means that the property has been calculated successfully. and then you go to general, you will see there are two. Atom number 1 is oxygen, contain 1. Atom number 2 is carbon, contains 2. So if you go to the formula, it is C1H4O1, CH4O. If you know the formula of methanol, it is CH3OH. You see, so what Aspen do? Aspen add these H means this H3 and one H means H4. So CH4O. And if you see the formula, this is also the same. Then you have to review the components. Review the components means if you go back to the problem statement, that you have to determine the molecular weight, the density, specific gravity, critical pressure, and critical temperature. So these values can be easily estimated by clicking on review button, that you have selected the components and then you click on the review button, and once after clicking the review button, this sheet is appeared where you can see this MW represents the molecular weight, PC represents the critical pressure, SG represents the specific gravity, and TC represents the critical temperature. And you require the same values: molecular weight, specific gravity, critical temperature, critical pressure, and density. So after that, you will have to select the property method. You can even do it before. There is no difference if you take it to number 2 and the other to number 3, number 4, and number 5. So in methods, you will have to go to specification, and in base method, you have to select these three property package: NRTL, ideal, and Peng-Robinson. If I go back to the problem statement, to the objective, we have to select ideal, equation of state, and activity coefficient. So ideal is labeled as ideal. This NRTL represents the activity coefficient model. This Peng-Robinson represents the equation of state, and the third one is the ideal. So you will select one by one, and in selected methods, which is this one, these three methods should appear, which is ideal, NRTL, and Peng-Robinson. Now, what is a property method? We have already discussed it earlier, but for a reminder, that a property method is a collection of methods and models that Aspen Plus uses to compute thermodynamic and transport properties. Basically, property method या जिसकी हम बात करते हैं कि ये वो मेथड है जो डिफरेंट मॉडल्स और डिफरेंट मेथड को कंबाइन करके या अक्यूमुलेट करके एस्पन प्लस को इनेबल करता है कि वो डिफरेंट थर्मोडायनेमिक और ट्रांसपोर्ट प्रॉपर्टीज को कैलकुलेट करे। और अगर आप सही प्रॉपर्टी पैकेज सिलेक्ट करेंगे तो ही आपके रिजल्ट्स एक्यूरेट होंगे। इट इज इंपॉर्टेंट टू चूज द राइट प्रॉपर्टी मेथड फॉर एन एप्लीकेशन टू इंश्योर द सक्सेस ऑफ योर कैलकुलेशन। अब कौन कौन सी थर्मोडायनेमिक प्रॉपर्टीज को कैलकुलेट करते हैं इस पर? फिगोसिटी कोफिशिएंट, एंथैल्पी, एंट्रोपी, गिब्स फ्री एनर्जी, वॉल्यूम, एंड देयर आर सो ऑन। Similarly, the various transport properties: viscosity, thermal conductivity, diffusion coefficient, and surface tension. So this is calculated by virtue or by means of property method and right property method. Now, the ideal property method is based on Raoult's law and Henry's law. The ideal property method accommodates both Raoult's and Henry law. This method uses the ideal coefficient, ideal activity coefficient model for the liquid phase gamma is equal to 1, ideal gas equation of state PV is equal to RT for the vapor phase, and bracket model for liquid molar volumes. Now, this method is recommended for the systems in which ideal behavior is or can be assumed. For the systems which are exhibiting the ideal behavior, you can select ideal property method. But for those systems which are highly non-ideal, you will go to the activity coefficient model, which I will told you. System at vacuum or low pressure, this will show ideal behavior. Very high temperatures, ideal behavior. Very small interactions, ideal behavior. interactions that can cancel each other out. So for these four systems, you can apply ideal property method. Otherwise, you cannot apply the ideal property method. Now, if you look at the thermodynamic properties, vapor mixture Vygotsky coefficient model is ideal gas law. Enthalpy entropy Gibbs energy, general pure component, ideal gas heat capacity. For density, ideal gas law, density, racket. For transport properties, you see different property packages are provided to you as well. So I will provide you these slides so that you can easily read the required property packages for thermodynamic and transport properties in case of ideal property method. We have already discussed in our thermodynamic lecture as well. Equation of state model PHIL liquid pure component Vygotsky coefficient. PHIV vapor pure component Vygotsky coefficient. Similar is for DHL molar enthalpy departure for liquid and same is for vapor. Then again molar gives free energy departure, molar gives free energy departure for vapor and liquid. Similarly molar volume for liquid and vapor gamma HL. So for these type of requirements we use equation of state model which includes Peng-Robinson, SRK, Soft-Bradstreet-Kwong, Chow-Cedar, and there are multiple models. Chow-Cedar is a special property method which is not included in equation of state, but there are different models available in equation of state. Then the activity coefficient model, which includes NRTL, Uniquac, Unifac, Van Laar, and Wilson. If you remember, we had discussed for the chemical systems having low pressure and then binary interaction parameters, we ended up in selecting these property methods. The activity coefficient model calculates liquid activity coefficients. It is recommended for highly non-ideal chemical systems and can be used for VLE and LLE applications. So again, the thermodynamic and transport properties models are available over here. So now we will go back to Aspen Plus, and before going to point number 6, we will solve the simulation till now. After opening the Aspen Plus, this window appears, and as you see, what's new? If you want to view the information, examples which are given in Aspen library, you can also load it. Training, models, events, announcement. So these are given over here. In file, you can save your simulation, or you can import, or you can even export, or you can even check what are the recent models which you had opened here. File, I will click on new, and in new I will click on blank simulation because I have not been given any idea what will I do. So I will simply click on blank simulation, but obviously there are different templates available over here for air separation, chemical process, electrolytes, gas processing, metallurgy, and so on. So I will click on blank simulation and create it. You can even double click on it for the set purpose. After that, this window has appeared. As you see in home, unit sets are present, which is METC bar. You can even click on it and select the suitable unit set, or you can go to this setup and go to specification. So you can see this METC bar is already clicked. And if you go to the calculation options, then these are the calculation options which are selected here. I will not go into detail of it because currently in start you will select auto or default conditions, then go to unit set, and you see these four units are placed over here. If you go to English and compare it with the slides, that the units given are the same, that mass flow in pound per hour, mole flow pound mole per hour. Similarly in case of MT, kg per hour, kg mole per hour, and same with temperature and pressure units different, and so on. After that, it's set up components, methods. If you write the chemistry, define solution chemistry for electrolytic system, and so on. Similarly, you can draw the structure. Method assistant, we have already discussed it, that we can select method assistant to choose the right property package, NIST, and analysis estimation, and so on. And this is the important part for you now, that you can select next, go to the next input sheet needing input. Why this is necessary? because if you do not know the simulation procedure, there is no worries, because at the start this can happen. But you can click on next button to go to your next part. For example, if I click on next button, it will take me back to the component sheet that select the component which you want to enter in, or with which you can wanna proceed. So as I told you that there are two ways of adding the component, but I will select the method which I have shown you in the slides, and then in the next video I will directly add component over here. So click on find, and in find you require two components. One is the air, click air and find it now, and you see this air is placed over here. I will click on air and I will add selected components, and as you see air has been selected. What is the second component? It is methanol. Again click on find now and scroll it a bit down to find the methanol over here, and you see methanol is placed over here. So click methanol, add selected component, and it has given you that do you want to replace the component air with methanol or add methanol to the list. So you want to add methanol to the list, as I have told you earlier. So add it and then close this window. So you see your two components have been added. Then click on next. I had told you that you can either select the property package earlier, or you can even select the property package at number 5th stage. So you click on, so in method filter, you see there are a lot of filters or a lot of families available over here which are common, which are commonly used: chemical, coal, electrolytic, and polymer, power, refineries, syngas, synfuel, water, and so on. So usually we select common, or even you can select all as well. Then go to the base method, and then there are a lot of methods available over here: chow cedar, NRTL with electrolytic model, ideal, NRTL, poly NRTL, Peng-Robinson, SRK, solids. These are the commonly used methods in Aspen Plus. So our first task is to select the ideal method, and after selecting it, click run. And after running, you see the results available. And if you go to check status, you did not find any message, means you have selected it correctly. Go to specification again, and if you check, you have selected currently ideal. Now you want to select the Peng-Robinson. So what you do, simply scroll it down and select Peng-Robinson, and you see in selected method Peng-Robinson has been added. Again click run, and after processing specification, results are available. And now you want to enter NRTL again, which deals with the gases and Henry's law, and you click run it, processing input specification and results available. And as you see, these three property packages has been added in the system in the selected methods. Now, as I have told you, you can even do it earlier, you can do it before, or you can do it at number 5. So it's up to you. After that, go to the molecular structure, and in molecular structure for methanol, if you go to methanol and click on structure, you see bonds, or the structure is present. Calculate bonds, and after calculating bonds, you see in general oxygen, a type is oxygen, contains number 1, unique number identifying an atom in molecule. Similarly for carbon, it doesn't define the number of atoms, it's the numbering, that it contains single bond. CO, atom type specification, and in formula you see in atom type it's C1O1H4. So this is the overall molecular structure of methanol. For air, it does not exist because air is not a single component. And if you want to draw for air, then you have to draw nitrogen and oxygen in it, which is not possible. So click on run, and you see results are available. After getting the structure of methanol, because you know methanol is a pure component, and for air it's a compound basically, but we are dealing a compound as a component in Aspen plus. सो डोंट गेट कंफ्यूज, आपको कंफ्यूज होने की इसमें जरूरत नहीं है कि एयर का क्यों नहीं आ रहा, क्योंकि एयर में देखें 79% नाइट्रोजन होती है और 21% ऑक्सीजन होती है, जो कि हम कहते हैं, लेकिन असल में तो बहुत सी चीजें होती हैं, आर्गोन भी होती है और ऑक्सीजन, वो जो नाइट्रोजन भी होती है, CO2 भी होती है, और डिफरेंट चीजें इसमें मौजूद होती हैं। तो आप लोगों ने उससे घबराने की जरूरत नहीं है। आप लोगों ने बस मेथनॉल का अगर देख भी लिया तो वो भी आप लोगों के लिए एनफ है कि उसमें कितने एटम्स हैं, उसकी सीक्वेंस क्या है। ये जो बॉन्ड है ये बेसिकली सिंगल बॉन्ड है, यानी कार्बन का सिंगल बॉन्ड है, ऑक्सीजन का सिंगल बॉन्ड है, तो इसलिए उसको उन्होंने नंबर 1 और नंबर 2 करके स्पेसिफिकली शो कर दिया गया। हाइड्रोजन का नहीं शो किया तो उसमें कोई इतना घबराने की जरूरत नहीं है, क्योंकि वो आपकी स्ट्रक्चर में शो हो रहा है और फॉर्मूला में भी डिपेक्ट हो रहा है। उसके बाद आफ्टर दैट यू हैव टू रिव्यू द प्रॉपर्टीज एंड गो टू स्पेसिफिकेशन, and in review button, if you click the review button, then you can get the various properties of air and methanol. This Sg is the specific gravity of air and methanol which we require. This Tc is the critical temperature of air and methanol. This Tb is the boiling temperature of air and methanol. Similarly, this Pc is the critical temperature of air and methanol. This Mw, molecular weight for air and methanol. This freeze point, freeze PT, is the freezing point for air and methanol. And similarly, this ZC is the compressibility factor for air and methanol. So you see there are a lot of properties available over here for the calculation. Click run and this window should be with results available. Now I will take you back to the PowerPoint's presentation and we will see what is our next task. Our next task is to build the simulation, and for this we have been given that methanol at 100 kmol per hour at 60 degree Fahrenheit at 14.7 psi and air at 1000 standard cubic feet per minute at 75 degree Fahrenheit and 14.7 psi. So what we do, we will add a mixer over here. Obviously a mixer means the mixing of more than one streams, but we will add the methanol stream over here and we'll take the methanol stream from here. So it means no mixing, the fresh methanol is entering and the fresh methanol is leaving. Same is the case for air. We do this when we want to study the various properties with respect to different property packages, because we are now moving towards our third task or our third objective, that we have determined the structure of component methanol. We have learned how to find and get the property value of pure component. हमने स्ट्रक्चर भी देख ली कैसे हम उसको डिटरमिन कर सकते हैं, कि हमने सिंपली क्या करना है, कैलकुलेट बॉन्ड पे क्लिक करना है और हमें उसकी स्ट्रक्चर भी मिल जाएगी, बल्कि स्ट्रक्चर तो ऑलरेडी उसमें मौजूद है। स्ट्रक्चर आपने देख लिया उसमें जाकर बॉन्ड करके कि कितने उसमें बॉन्ड्स हैं, और फिर आपने देख लिया कि उसकी प्रॉपर्टी वैल्यूज जो कि क्रिटिकल टेम्परेचर, प्रेशर, बॉइलिंग पॉइंट, मॉलिकुलर वेट, डेंसिटी, स्पेसिफिक ग्रेविटी, सारी वैल्यूज आपने उसमें डिटरमिन कर ली। और आपका जो थर्ड ऑब्जेक्टिव है वो है कि कैन ऑब्जर्व डिफरेंस विद आइडियल इक्वेशन ऑफ स्टेट एंड एक्टिविटी कोएफिशिएंट। तो मैं अब इसमें ये करूंगा कि मैं मेथनॉल लेके चलता हूँ और मेथनॉल को सॉल्व करके मैं ये सारा कुछ करता हूँ। आप लोगों ने क्या करना है, व्हाट यू हैव टू डू, यू हैव टू टेक एयर एंड डू द प्रोसीजर द सेम वे which I will be doing right now. So if you see, after clicking on this simulation, this window has been appeared, and this bar you see is red labeled. When there is more specification required, red. When all specification completed, results available. And this one is the model plate can simulate unit operation by putting in flow sheet. Means what we will do, we will click on here and then we will paste it over here. I will show you how. The same, if you see, mixer, splitter, separator, exchanger. So it has been divided into blocks: column block, reactor, pressure change, manipulator, solids, separators, and user models. So first thing you need to do is to select the material stream. If you see here, then a lot of streams are present over here: material, energy, work stream. So you will select material stream over here, you will paste it, and you will give the values of these material streams for methanol and water. This is the flash type. I will take you and I will show you what are the properties required. You need to enter two properties out of three here. Means out of these three properties, what are these three properties? Temperature, pressure एंड वेपर फ्रैक्शन. तो इन तीन में से दो प्रॉपर्टीज देना आपके लिए जरूरी है. ये इसका डिग्री ऑफ फ्रीडम है. देन यू हैव टू गिव द टोटल फ्लो basis which is the mole because you are currently dealing with mole. Same is the case here that you have selected standard cubic feet per minute and that is in 1000, and here it's in kg mole per hour and it's 100. After that you have to give the value of composition. So you select mole fraction because you are dealing with the mole values. If it's mass, then you could have entered mass fraction, and we will discuss it later in stages. And then you have to give the mole fraction value. If it's pure, then the value will be 1 because you know final answer is 1, and for air here it will be 1. After that you will add a mixer over here and the final streams, and once after doing it click on run, and after running you see the results has been generated. Now these results do not contain these values currently. If I take you back to the problem statement, that viscosity, heat capacity, thermal conductivity, enthalpy is present, but vapor pressure is not present. So what you will do, you will click on add properties and you will search specific gravity over here. And once after selecting specific gravity, click OK, click OK, and this specific gravity will appear. Similarly, select heat capacity, select thermal conductivity, and select vapor pressure. So I will show it to you right now. We will go to the simulation. You see viscosity, heat capacity, heat capacity at constant volume, thermal conductivity, and same values for here. One thing you need to make sure that methanol is in liquid phase. So you will select these properties under the heading liquid phase. The air is in vapor phase. So you will select these properties for air in vapor phase. I will show you once we will go to the simulation. And then we will change the property method. How we will change it? We will go to the blocks, and in block option, we will select Peng-Robinson, and then we will calculate the value. Then we will select NRTL, and then we will calculate the values. And then we will come back finally to the sheet at the end once we have done with the simulation. So let's go back to Aspen Plus and simulate it. So once after doing it and the results are available, this please make sure that once before going to the simulation environment, these results are available. If these results are incomplete or contain some warning, then better to remove these warnings before going to the simulation. So click on simulation. जब आपने simulation environment में जाना है तो उससे पहले पहले आपने ensure करना है कि कोई warning या कोई error रह तो नहीं गया, क्योंकि अगर error रह जाएगा तो फिर वो आगे आपकी simulation converge नहीं होगी. So this is the main environment, simulation environment. If you see in setup, this is the same setup as we have discussed. In specifications, units are present, input mode, steady state. We are dealing with a steady state simulation, not dynamic. And if you आपको पता है स्टेडी स्टेट का मतलब है कि विद रिस्पेक्ट टू टाइम कोई चेंज नहीं आ रही. डायनामिक में तो आपको पता है वो कंट्रोल एनालिसिस और आगे सारी चीजें शुरू हो जाती हैं एंड सो ऑन. सो in home you see units have been selected. This is the next button, and I have told you earlier कि अगर आपको नहीं समझ आ रही कि अगला स्टेप क्या है तो सिंपली नेक्स्ट बटन पे क्लिक करें, वो आपको नेक्स्ट ऑप्शन पे ले जाएगा. लेकिन जब आप सिमुलेशन में इंशाल्लाह एक्सपर्टीज ऑब्टेन कर लेंगे तो फिर आप लोगों को इस नेक्स्ट बटन की भी जरूरत नहीं रहेगी. लेकिन चूंकि अभी स्टार्ट है तो हम इस नेक्स्ट बटन को यूज फ्रिक्वेंटली करेंगे. देन रीसेट बटन, दैट इफ यू वांट टू रीसेट इट एंड रीरन द सिमुलेशन अगेन फ्रॉम zero, then you can do it. Then model summary, stream summary, utility cost, input history report. You can even observe various things related. Sensitivity analysis, you can do it. That what is the impact of certain parameter on simulation, data fitting, and azeotropic. So we will discuss it in later stages. Coming to the model plate, if you see this one is the material stream, and if I scroll it, then this one is the heat stream, and this one is the work stream. In mixer splitter, you see this one is a mixer, stream mixer, also used to combine heat or work stream. This one is the splitter, stream splitter divides feed based on splits specified for the outlet streams. Then this one is S split, substream splitter. Then you see there are different separator types, heat exchanger types, columns, distillation columns, various type of distillation columns present, reactors, pressure changes. So we will discuss it one by one in our upcoming lectures. What you do, there are two ways of doing it. Either you click material stream, place it over here, and then click the block. I usually do it by clicking the first block, the mixer. What you do, I will show it how. Click it, right click it, and place it over here and give it a name as mixer. You can even click on it. You see these red blocks are appearing, red dots are appearing. So you can even drag it and extend it as well. And then click on material stream. And if you click on material stream and you currently haven't clicked it, then you see there are two red arrows appearing and one blue arrow appearing. If I go to the red arrow to see what it demands feed required one or more if mixing material stream. And this one is the product required if mixing material streams. This is basically a mixer which is required to mix more than one streams, but it is converged once you give one input value, one stream. It means its degree of freedom is zero. It doesn't require any input in itself. Why I have said it degree of freedom is zero? Because if I select other components, such as if I select pump, then I have to give the outlet pressure of pump. It means one value is required to convert the pump. But if I enter or if I connect one material stream and one product stream, and if I give the specification of material stream, it will converge automatically. I will show you how. कि अगर मैंने मिक्सर को सिलेक्ट किया है और मैं एक स्ट्रीम देता हूँ इनपुट की और एक ही स्ट्रीम देता हूँ आउटपुट की, और मैं इनपुट की सारी स्पेसिफिकेशन जो रिक्वायर्ड स्पेसिफिकेशन है वो स्पेसिफाई कर देता हूँ, तो उससे क्या होगा, वो कन्वर्ज हो जाएगा। यानी मिक्सर को इटसेल्फ आपको कोई भी वैल्यू देने की जरूरत नहीं है। जब आप इक्विपमेंट को कोई वैल्यू देंगे, इसका मतलब है फिर उस इक्विपमेंट की डिग्री ऑफ फ्रीडम आएगी। So how you will add a material stream? You will click here and then connect it with and name it as, for example, methanol, and then click here and place it where you want and label it as S2. It's up to you. Nomenclature is up to you. There is no hard and fast rule for nomenclature in at the start, but obviously when you will follow and you will do more simulations, then you will have to select the proper nomenclature. Now click on this methanol stream, and you see in specifications in flash type, I had told you that there are three parameters which you have, out of which you have to give two parameters. यानी आपके पास तीन पैरामीटर हैं, टेम्परेचर, प्रेशर और वेपर फ्रैक्शन। इसमें से आपने दो पैरामीटर्स देने होते हैं लाजमी तौर पे। अगर आपके पास टेम्परेचर प्रेशर गिवन है तो आप यहाँ से फ्लैश टाइप में टेम्परेचर और यहाँ से आप प्रेशर सेलेक्ट कर लेंगे। अगर आपके पास टेम्परेचर और वेपर फ्रैक्शन गिवन है तो यहाँ से आप टेम्परेचर और यहाँ से आप वेपर फ्रैक्शन सेलेक्ट कर लेंगे। अगर आपके पास प्रेशर वेपर फ्रैक्शन है तो यहाँ से आप प्रेशर और यहाँ से आप वेपर फ्रैक्शन सेलेक्ट कर लेंगे। सो currently the values which we are given, that methanol is at 60 degree Fahrenheit, 14.7 psia and at 100 kg mole per hour. So this is temperature. In state variables, enter the value as 60, but it is not in degree centigrade. So scroll it down and select degree Fahrenheit. Similarly, 14.7 and it's in psia. So you can scroll it down and select psia. So out of these three values, you have to give two values. A total of four values are required. Two out of these three, one value of flow rate and one of composition. So it means the degree of freedom for a single stream is 4, that you have to give the 4 parameters. आपको 4 parameters देने ही पड़ेंगे अगर आपने अपनी एक स्ट्रीम को भी कन्वर्ज करवाना है तो। ब्लॉक की तो बात अलग है, ब्लॉक क्या है, मिक्सर, स्प्लिटर, रिएक्टर, कूलर, हीट एक्सचेंजर, वो ब्लॉक है। लेकिन जो स्ट्रीम है वो ये है जो आपने भी एंटर किया, जो कि अभी मटेरियल स्ट्रीम है। अभी अब मटेरियल स्ट्रीम की बात करें, एनर्जी स्ट्रीम की बात नहीं कर रहे। एंड देन इन टोटल फ्लो बेसिस सिलेक्ट मोर, एंड दिस इज 100 kg मोल पर आवर। जब आप एयर सॉल्व करेंगे तो आपने यहाँ से स्क्रॉल डाउन करके दिस इज स्टैंडर्ड क्यूबिक फीट पर मिनट, SCFM, इसको सिलेक्ट करना है, ठीक है। एंड आफ्टर एंटरिंग द फ्लो यू हैव टू सिलेक्ट द कंपोजिशन, and in composition you see mole flow or values are present, and in mole flow instead of selecting it, select mole fraction, and obviously mole fraction has no units, and in methanol add it as 1. After you have added 1, this run block or the run option is enabled. It means the thing which I was telling you earlier, that you have to just do the connections, give the value of feed stream, the specifications, and it will be converged. And if you click on run button, then you see results are available. When these results are available, it means no error is present in the system. You can check status, or you can go to control panel to see no warnings were issued during the input translation. Now right click on it and go to stream results, and in stream results you can see that description, there is no description we have provided from mixer. S2 is coming from mixer, and methanol is going to the mixer. This is the conventional mode. We will also discuss it. Mixed substream, the phase is the liquid phase. Temperature in degree centigrade for inlet and for outlet, and same is the case for pressure. Molar vapor fraction is 0. Molar liquid fraction is 1. It means it's a liquid phase system as already shown over here. Then the values of enthalpies and molar enthalpy, mass enthalpy, molar entropy, molar density, mass density. So these values you can also find it from here. And if you remember, we had talked about the density. So this density is basically dependent on the properties which you give on the specification. So you can also take these values from here as well. And same is the case for molecular weight, which was we have taken it, and it is independent of the properties given. Now, if you see, this liquid phase is present, there is no vapor phase present because it's a liquid entity. When you will solve air, then vapor phase will be present over here. So go to liquid phase and you see all these values are present over here. So click on add properties because you want to check the specific gravity, you want to check the vapor pressure, you want to check the thermal conductivity, heat capacity. So click on add properties, and once after adding properties, you see you find properties is coming, and enter a search string, and you want to search specific gravity, and these are the different specific values available: specific gravity reference here 60 degree Fahrenheit, standard specific gravity for a petroleum mixture. So you have to select specific gravity, click OK and OK, and you see the specific gravity is added over here. Again, follow the same steps and select heat capacity, and this is heat capacity of a mixer, ideal gas heat capacity, but you have to select heat capacity for pure component, which is CP. And once after selecting it, you see this is heat capacity for pure component, which is given in calories per mole Kelvin. In our slides it was BTU per pound mole Rankine, so you can even select it as well. After that, click on add properties, heat capacity, and that is CV, heat capacity constant volume, CV, and select it. And again, same as the case, heat capacity constant volume. Similarly, thermal conductivity, and you see thermal conductivity for pure component because it's not a mixture. If you select mixture, then you're selecting the wrong value. And thermal conductivity, scroll it down, and you see, so specific gravity, heat capacity, For pure component, CV, thermal conductivity, and obviously the values of enthalpy are placed over here. So you have achieved your first target, that you have got the values of heat capacity, thermal conductivity, specific gravity, and enthalpy over here. But what is your next task after doing this? You have to vary the property package. So how you will vary it? Firstly, go to main flow sheet. If you click on this and do some other things, then it will disturb. बस कहने का मकसद ये है कि आपने जब भी कोई और चीज़ सिलेक्ट करनी है, जैसे अभी आप तो मैं नेक्स्ट बताने लगा हूँ जो चीज़, तो आपने सबसे पहले फ्लो शीट पे जाना ताकि आपकी जो ये वाली सेटिंग है ये खराब ना हो। अदरवाइज आपको ये सेटिंग दोबारा करनी पड़ सकती है, ये वैल्यूज दोबारा सेलेक्ट करनी पड़ सकती है। सो आफ्टर गोइंग टू मेन फ्लो शीट, इफ यू सी on your left side, then in Mixer, these block options are available. So click on these block options, and currently the property method selected is NRTL. Why NRTL? Because at third spot or at the end, if I take you back to properties environment and we go to the methods specification, currently NRTL is selected. So it has automatically taken the NRTL value. And now you want to vary it to Peng-Robinson. So what you do, you will click on Peng-Robinson, and just one thing you need to do is I will take you back to the values, heat capacity, constant volume, and in liquid phase as well. अब ये सारी सेटिंग मुझे इसलिए करनी पड़ी क्योंकि मैं एक डिफरेंट शीट में चला गया था, तो इसलिए दोबारा से मुझे सेटिंग लिक्विड फेज के अंदर आके करनी पड़ेगी. एंड क्लिक रन, and once after clicking run, you see there is a lot of difference in the values of heat capacity and thermal conductivity. Earlier these values were 20 and now it's in 26. Similarly, ideal, and then again click run, and after processing input specification, check the results available, and you see the values which were 26 are now 20.3968. So on the same pattern, solve it for air as well. Now I will take you back to the presentation file, and we will see the last slide which I had told you we will discuss it at the end. So in this slide, comparison of ideal with equation of state and activity coefficient model. If you see, these are the results for air and methanol in the case of ideal property method, in the case of NRTL, and in the case of Peng-Robinson. For a pure component which was methanol, the results for ideal and NRTL method are same as their calculation bases are same for evaluating component and thermodynamic transport properties. For the liquid or for the pure components where which we are dealing with, the ideal property package and NRTL property package gives us the same results. However, the results for equation of state model are slightly different for air and methanol. This PR, which is the Peng-Robinson model or the equation of states, are usually applied where gases are involved. The results predicted for air are more precise than ideal method for air. However, for methanol, which is the liquid state, the results might have inaccuracies as we have shown. As if I take you to the heat capacity value, which is over here 26.468, here it is 20.3968, and here it is 20.3968. So you can see there are the ideal property method and NRTL are okay for or best suited for the liquid, which is the methanol. But for Peng-Robinson, this method, but for the liquid where we are using Peng-Robinson, it's not advisable or not suggested to use the Peng-Robinson. मतलब ये है कि आपके पास जब methanol जो कि liquid state में है, तो आप Peng-Robinson को यूज ना करें. आप NRTL यानी जो एक्टिविटी कोफिशिएंट मॉडल है, जिसके अंदर अभी हमने करंटली NRTL सेलेक्ट किया, लेकिन सिर्फ NRTL नहीं है, और भी मेथड्स है, यूनिक्वैक है, यूनिफैक है, विल्सन है, वेनलार है, तो आप उनमें से किसी को सिलेक्ट कर सकते हैं, या आप आइडियल को सिलेक्ट कर सकते हैं, लेकिन आइडियल को भी आप उसी टाइम सिलेक्ट करेंगे जब आइडियल बिहेवियर शो होगा। अगर नॉन आइडियल बिहेवियर है तो फिर आप कीवर्ड्स के लिए एनआरटीएल शो यूज करेंगे। लेकिन जो गैसेस हैं, जैसे हाइड्रोकार्बन गैसेस हो गई, मिथेन, इथेन, प्रोपेन एंड या एयर है आपके पास, तो उसके लिए आप पेंग्रोबेंसन को ज्यादा यूज करेंगे। बिकॉज इफ यू सी कि हीट कैपेसिटी एयर के लिए इन दोनों के केस में सेम है, लेकिन इस केस में डिफरेंट है, और ये ही इसकी एक्चुअल हीट कैपेसिटी वैल्यू होती है एयर की, जो कि आप लिटरेचर से भी चेक कर सकते हैं। ठीक है जी। सो दैट्स ऑल फ्रॉम दिस लेक्चर ऑफ एस्पेन प्लस दैट वी हैव। फर्स्टली, if I take you back to the objective, that we have known the structure of the component, we have found and got the property value of the component, and we have observed difference in ideal, equation of state, and activity coefficient property methods. So that's all for this lecture. Thank you so much.